Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about a process synchronization solution, Semaphore. Right, basically it is proposed by registered Dijkstra, which is a technique to manage a concurrent process. Now this semaphore is a simple integer value, that is it may be either 0 or 1. The integer value semaphore may be either 0 or 1, and the condition is it is a non-negative value, no minus, right? So directly get into the topic with one example. This classical example is going to make you understand what is this semaphore, that is a solution which is provided for process synchronization, right? So here we have three variables. One is semaphore, that is S. Another one is wait function, that is P, which is to test. If any process want to get enter into the critical section, it will use this wait process to test that whether any process which is already inside. If it is any process is already inside, in the basis of mutual exclusion, I need to wait, right? This is the second function which is used to call it as signal, and it has the name as a variable as V, and this particular function is going to increment the value. If some process want to get outside of the function, that is the critical section, it will increment. It will test initially and it will increment when it is leaving the critical section. Now I have described this three particular variables, and this variable is effectively used in this definition of wait as well as the definition of signal, right? So let's get into the process directly. Now I am going to start with this wait. Now say for example, now some process, right? Say for example, P1 is approaching this critical section, right? Now P of, if I am approaching, I need to use this wait. I am going to test this. P1 is going to test that. If it is someone is inside, P1 has to wait. If no one is inside this critical section, this P2 will get enter. Let's see how this P1 is getting enter into this particular critical section, right? P of semaphore S. P in the sense, I am going to test. P is to wait. I am going to test. P1 is testing it. The semaphore value, I told you already, this semaphore value will be either 0, yes, can be either 0 or 1, right? So now I am going to check it, that is P1 is checking it. The condition here, while S is less than or equal to 0. I told you already S cannot be a non-negative value. So I am checking it, S is less than or equal to 0, semicolon. This while loop can be broken when it is false. If it is true, then nobody can break this while loop. That means P1 is testing this, that is it is finding that whether S is either 0 or 1. Now P1 is finding if it is the S value is 0, P1 cannot get enter. That means what? Some process is already inside this critical section, right? Say for example, now P1 is testing that, it is finding that S value is 1. That means what? Now say for example, S is 1 is less than or equal to 0. So now the condition is false, right? 1 is not, that is less than or equal to 0. The 1 is actually more than this value. So if the condition is false, it will break this while loop. Who is breaking this while loop now? P1 is breaking this while loop. Now P1 is getting enter into this particular critical section, right? When there is no operation, when value of S is 0, that means someone is already inside. P1 has to wait. Now P1 is checking that the value of S is 1. So it will break this while loop and get into the process. Now let's check. Now what is the value of S? Value of S is equal to 1. Who is checking that the value of S is equal to 1? P1 is checking. When S is equal to 1, P1 is getting enter. Now let's see what P1 is doing now. Now P1 should not let any other process to get enter into this critical section. Now what this P1 is doing? It will decrementing the value of S. What will happen? S is now it is 1. Now S is decremented. That means what? So S value will become 0 now. Now assume that some other process, now P1 is inside, some other process is approaching this semaphore. Now what is the value of semaphore? This P1 has made the semaphore value into 0. 0 in the sense the condition is true. The yes is 0. 0 is less than or equal to 0. The condition is true. No process cannot break. Any process who is waiting outside cannot break this while loop. Why? Because P1 has made this S value into 0. That means P1 is inside. So nobody can get enter into the critical section when some process is actually inside. Now P1 is inside, nobody can get enter. That's a process. Now this logically proves that if someone is actually acquired the critical section, nobody can get enter. This is the one more possible solution for process synchronization. Let's see what this P1 is doing with this particular signal function. Now signal is a function which is actually to increment. I told you already. Now signal in the sense I need to release it. When the process 1 is already inside, want to leave this critical section. I want to leave this critical section when process 1 completed its task. Again the same process P of, that is wait signal, we are going to now this will become V. Why? Because I am going to use this signal variable name of the signal is V. So V of semaphore S. Now the value of the semaphore will be incremented. Now tell me, after this P1 is getting entered into this process, it set the value of S is equal to 0. Now S is equal to 0. Now what happens? S value will be incremented. Now S is equal to 1. So this will be done when P1 wants to go out of the critical section. Now S value will be set into 1. Right? So 1 is less than or equal to 0. If any other process who is checking to get entered in the critical section, if it finds the S value is 1, that is the condition is false, it can break inside. That is the way which is provided by this P1 when it is getting out of the critical section. So S value I am putting over here, the main task of this semaphore. S value is equal to 0 in the sense someone is inside. S value is equal to 1 in the sense the semaphore is free. It is free. So anybody can get enter. Anybody can get enter into that particular critical section. See here, P1 wants to leave this particular critical section. It is making the value of S. That is S. When I am getting inside, I am making this 0 into 1. Right? So I am making that particular 0 into 1. I am making that value 1 into 0 and I am getting inside. When I am inside, I am making this 1 value into 0. Nobody who is waiting outside can get inside. Now I want to leave this value, that is semaphore. This semaphore has to be set. So how this value has been set? This process 1 has to leave this particular critical section. It is setting this value S is equal to 1 by using this increment. Increment in the sense we are using this signal. The variable of the signal is V. Right? So when I am leaving this, I am making this S value into 1. So if anybody who is waiting outside can check that value semaphore, if it is 1, that means critical section is free, can get enter. If it is 0, there is somebody inside. Thank you.